Well, welcome to another session of CNOS. And I think it's imperative for us to start working on preparation of obviously the assessments that are coming up. And I think we've been discussing the assignment at large. I think we're all sorted as far as that particular setup there is concerned. I think the only question, like I mentioned in our previous session, that was distinctively slightly involving, I guess if you look at it from a different point of view, was 2.3. But obviously, as far as the rest of the assessment is concerned, I think you should be sorted in that regard, because ultimately all content that is distinctively relevant there has been covered. And if you're still not too clued on what's happening in that regard, please have a look at obviously the recorded sessions that are there as far as content is concerned. So we've got your test as well that is coming up. I think, if I'm not mistaken, that is possibly around the 14th of October. If there's any changes there, then naturally, I think the campus will give you a shout in terms of what's happening in that regard as well. But naturally, as far as your particular program assessment schedules are concerned, I think the date that has been listed there is the 14th of October, still labeled as a take-home assessment, but obviously that can change. So it's obviously imperative for us to obviously prepare accordingly as far as these particular assessments they are concerned. I think it's also equally important to understand that when it becomes a take-home assessment, obviously while the questions might be the same, you might discover that obviously the content that you now need to plug in would need to show more of your understanding of concepts and your understanding of obviously module sections at large in that regard, as opposed to just regurgitating content exactly as it is, either from your textbook or any particular material literature that you'd use, slides inclusive. So it's important to understand that when it's you actually come into campus and you sit down and write the exam on site, there's a difference there in terms of the way in which you plug in your answers, as opposed to something that is take home, because obviously with take home, it's literally take home is open book, right? So in that particular instance, the way in which you now incorporate content has to have obviously the appropriate referencing put in place. And at the same time, it's also important to understand that more marks are going to be allocated to individuals that show an understanding of concepts, as opposed to individuals that literally just plug content out of the textbook and plug it into your assessment document as is, without any particular inclination in terms of your understanding in that regard. So you'll discover that while the questions will remain the same, so in terms of content per se, right? So still coming out from the same learning units, but the questioning in terms of technique might be slightly different, because now you'll be asked to look at a lot of questions that would look at analysis, that literally look at discussions and so on. And you'll find that the whole concept of you having list-based questions, for instance, or define questions becomes null and void in that event. Why? Like I was mentioning earlier on, because it's an open book, there has to be some understanding that is displayed or demonstrated by the candidate when they're obviously answering questions in that regard. So things like briefly discuss, compare, and obviously justify when it comes to certain environments are the type of questions that you'll discover, and obviously associated with take home. So today we're obviously going to look at the 2019 paper. Obviously, that was written in a different setting. And then I think in other concurrent sessions, we'll then look at the 2020 paper, which was written within the take-home environment, for you to actually see the distinctive difference there and what it is that you obviously need to plug in to ensure that at least you pass that particular assessment in that regard. So I think what is also important is to ensure that we remember, I think this is or revisit rather, what's happening in terms of the actual assessments at large. What are the actual percentages associated with configurations, and then naturally what it is that you are supposed to be plugging in order for you to get the appropriate mark in that regard. Remember, your generic pass mark there is obviously going to be the 50%. And then obviously if you're below that, when it comes to the actual finals, and you're between your 40 and 48, then naturally you qualify for a supplementary exam in that regard. So we still have the ICE component naturally, and I've been mentioning for lectures on end now that as far as ICE is concerned, the review questions that are at the end of the chapters that we conclude are part and parcel of ICE as well. So currently we've undertaken, I think it's 12 chapters now. I think we only have 2 chapters that are left in terms of completing module content. Right, so it was imperative for you to be completing those particular review questions, because I think we had some, I wouldn't even say a discrepancy, but I would want to call it possibly a deliberate misunderstanding when it came to your help desk environments there, where we were mentioning that obviously each particular task from every distinctive learning unit there is applicable as ICE, where we had a couple of individuals now for some odd reason not remembering us mentioning that, or even dedicating sessions to completion of these particular ICE tasks. So I'm going to say it again, just make sure that the review questions that are at the end or the conclusion of each individual chapter, as far as your prescribed textbook there is concerned, is considered as ICE in particular. So make sure that you complete those accordingly, and obviously ensure that you send them through as far as basic submission there is concerned. And you also discover that not just from an ICE component, but if you look at the actual exam as well as your test, most of these questions are also going to be plugged in from those review questions. So it's not just a question of you contributing to your ICE, but at the same time also looking at preparing you for the assessments that are obviously to follow, specifically your test and exam in this regard. So if you look at the whole ICE component, obviously it's your 4 best as far as submission there is concerned. That's why it's important for you to actually complete much more than that, to ensure that at least you get the relevant mark in that regard. So there's a 10% component that we're all familiar with across all modules, literally. And then when it comes to your test, you've got a 25% allocation there. Assignment is 30, and then naturally your exam is 35%. That gives you a total of 100. And like we mentioned before, your pass mark is 50 in that regard. So when it comes to the actual test itself, you're looking at content that has been covered from learning units 1 to 4, which distinctively translates to chapters 1 to 8. As far as your prescribed textbook there is concerned. And then when it comes to the actual exam itself, it's obviously all learning units, all distinctive chapters. So that should be learning units 1 to 7, and that's chapters 1 to 14, as far as your prescribed textbook there is concerned. Naturally, with the assignment that we've already started on, again, content has been covered in that regard, learning units 1 to 5. And like I mentioned before, that would directly translate to chapters 1 to 10, as far as your prescribed text would go. So yes, while when you look at the test, they'll mention that the sources that are required there is just distinctively your textbook. When it comes to the assignment, it's not just a textbook, but obviously you've got additional material that you obviously can use as well to ensure that you complete this particular assignment accordingly. So again, like I mentioned before, especially if you look at your 2.2, I think, and as well as your 2.5 all the way to 2.8, as far as your assignment there is concerned in terms of questions, that particular content you'll find, obviously, as far as the recorded sessions there are concerned, like I mentioned before. So what we want to do today, like I mentioned a couple of moments back, is just look at the 2019 paper, familiarize ourselves with the way in which CNOS is distinctively assessed, and naturally understand exactly what to plug in and how to obviously answer these particular questions, as well as the actual answers there in terms of the past assessment papers there. Remember, they give you more of preparation platform, really. Yes, you will discover that in most instances, like you experience obviously with computer architecture, that most of these questions are literally recycled, right? So in terms of understanding these particular questions, I think it's important to avoid cramming. I think I've mentioned this a couple of times before, but understand the concepts at large, because if a question comes in, the same question can come in across multiple papers over a number of years, right? But the way in which that question is asked might slightly be different as far as techniques they are concerned. So if you end up cramming specific questions or cramming specific content, if it's asked in a different format, then it's going to be very easy for you to provide the incorrect answer in that regard, right? Why? Because you haven't gotten the understanding of the concepts in that regard. So it's always important to take cognizance of that particular fact. There's a difference when you look at memorizing steps, when it comes to possibly any particular theory, or when it comes to certain things like if you're discussing computer architecture as an example, when it comes to dismantling a machine, or when it comes to upgrading certain components like your RAM and your CPUs and so on. Obviously, there are distinctive steps that won't change across any particular platform that you distinctively work with, right? But it's important to understand that when it comes to other sections, as far as content would go, that it's imperative for you to get an understanding of the concept, right? So whichever way it's asked, you already have knowledge in the background there to obviously provide the right and appropriate answer. So just ensure that you avoid the cramming, just to obviously, again, avoid losing out on marks as far as your basic assessments would go. So that's the overview. Naturally, as far as your assessments are concerned, I think this we covered in our very first lecture, but I thought it was also imperative for me to look at it again today, because we now starting with revision of these particular assessments. Obviously, I think possibly after our test, we can then conclude module content. I think, like I said before, it's the 2 chapters that are remaining, which is the last learning unit, literally, that I will need to go through in terms of content. And then again, after that, we'll need to then start preparing for the actual exam to ensure that we're good to go as far as the module at large there is concerned. So let's have a quick look at what's happening with the actual past paper that we've got here. And then it enables you to obviously gauge where you're at as far as content would go, as well as preps in general is concerned as well. So you've got your natural paper that you'll obviously need to conclude in a 60-minute period, normally given between 5 to 10 minutes reading time as far as your particular setup there is concerned, just to obviously familiarize yourself with the paper and possibly mark or identify the certain questions that you might want to start completing first, or taking down notes first for before looking at others. So when it comes to formats, I'm not entirely picky, like I mentioned before, when it comes to the way in which you actually answer the question paper. But it's imperative for you to ensure that you obviously complete a section before moving on to the other one. So if you are sitting in for this exam, right, or test rather, what I'd advocate for, let's assume that you've got maybe 3 or 4 questions. You find that you're more comfortable with answering possibly question 3 first before moving on to question 2, or before moving on to question 1, and so on. Ensure that when you start with question 3, you complete the entirety of question 3 and you label it accordingly, right, before you move to another section. Avoid a scenario where you answer part of question 3, then you move on to 1, then you come back to another part of question 3, and so on. Just ensure that if you start with a question that obviously, or if you don't go within a chronological order, ensure that whatever question you start with is completed in its entirety first, before obviously moving to the next question. And then the other thing as well that you need to take into consideration now is that if you're not coming in to sit for this particular assessment and it's a take-home assessment, then it means that whenever you're answering the questions, they have to be in chronological order, because obviously there's no reason behind you starting with a different section before you move on to the other one. So the take-home assessment, because it's open book, you've got your research available for you. Ensure that you answer in a chronological order, right? But when it comes to you actually coming in and sitting for this assessment, then you can start with whichever question that you deem is more comfortable, but ensure that it's completed first in its entirety before you move on to the next one. So normally you find with these papers, because it's certificate level, you're looking at your multiple choice questions, you're looking at your match columns, fill in the blanks, and then naturally, sometimes you might also encounter the true false type of questions where you will be required to identify either a false statement or any particular false contribution as far as these particular questions would go, and then give your reason or state the reason why it's false or correct that particular statement. And then obviously marks are allocated accordingly in that regard. Then you will also have a bit of a scenario-based setup or long-based questions where you're either given a scenario, and then from that scenario, you're now supposed to answer questions accordingly, or alternatively, you've got more, like I was mentioning earlier on, just long-based questions where you're looking at definitions and possibly comparisons, and then also looking at justification of certain choices when it comes to your particular setup that is there. I think with your CNOS, you might also get some calculation-based type of questions, especially when it comes to the IP setup. So obviously IP version 4 and 6 in that regard. You might also need to ensure that you understand specifically. I think with IP version 4, you should be sorted, considering that you're looking at that same content as well when it comes to network architecture, where you might need, I would say, added attention, maybe if you want to look at it from a different perspective, would be your IP version 6, right? And in this particular instance, again, content has been discussed under the CNOS platform. If you've missed that session, please make sure that you always have a look at the recorded part as far as your setup there is concerned. So you've got the first section there, or literally the first question, which is your multiple choice. And then you've got the second question, match columns. Then the third question, the 25 mark allocation there, is now your longer based questions. As you can see, mark allocations would include your 8, 5, 5 in that regard. So you've got more marks allocated as far as the actual questions would go. And then you've got another fourth question as far as this particular paper is concerned, 20 mark allocation in that regard. Again, like I mentioned before, you've got more marks that are allocated in that regard as far as the actual paper at large there is concerned. But obviously, when you look at your multiple choice based questions, it's 1 mark a piece. Normally, when you find certain instances, especially from an exam point of view, they might be a bit generous and allocate 2 marks a piece for your multiple choice based questions. But ultimately, 1 mark is more than enough in that regard. And then same difference would apply for your match columns. In this particular instance, you find 2 marks a piece as far as matching the actual description with the term accordingly. In some instances, like I mentioned before, that could be dropped down to only 1 mark a piece as far as your contributions they are concerned. But that obviously depends on the actual paper as far as configurations would go. So I think let's start looking at the first question there, just to ensure that we're all on the same page. You'll also be given a bit of a scenario in that regard. So when it comes to your take-home assessments, right, if it continues on that particular path, you'll discover that some of these multiple choice-based questions would also work within the same environment as your either long-based questions. Why? Because you're possibly just given a scenario and then asked to provide an answer without a list of choices that are there. So this particular question, if it was to pop in or it was to be part and parcel of a take-home assessment, just for argument's sake, your question would literally end there. all right? And then you're asked to actually give an actual contribution in that regard. So it's important to understand. That's the reason why I was saying that it's important to obviously get the understanding of what's happening in as far as your particular assessments would go. Although there's still an argument that every which way I'll have my particular material or resources to use. But again, in the same instance, you will also even find that with your particular sit-in exams or assessments, a similar type of question will still pop in and end there, and you'll be asked to actually provide the actual answer without a list of choices that are there as far as your particular setup there is concerned. All right. So when it comes to 1.1 there, we've got a bit of a scenario there, and they've just mentioned that you've got some particular type of hardware, literally, that can be added to a computer system without having to restart the machine. Remember, this is more for the later day type of computing mechanisms. I think over a number of years now, there was a point where, especially if you look at just for argument's sake, the Windows XP era, there were certain instances where if you were adding certain hardware, especially when it came to such legacy connections like your PS2 configurations there for your mouse and keyboard. In that regard, when you plug in that particular PS2 mouse or keyboard while the computer system is running, to ensure that the actual device registers on the system, and for you to be able to use it, you would obviously need to restart the machine in that regard. So that could be that was a bit of a cumbersome process in all honesty, but obviously that was kind of addressed when you look at it from USB configurations, for argument's sake. When you plug in a USB keyboard or mouse now, as far as your environments would go, there's no need to literally restart the machine as far as your particular registration or usage of that particular device there is concerned. So there's a specific term rather that is associated with that. Literally, that's distinctly what they're asking for. So after a particular period, that device driver is automatically loaded, and obviously the hardware is available to applications as well as the actual user. Right. So remember your device drivers. We've mentioned these a couple of times before. What you're actually looking at in this particular instance, as far as your distinctive setup there is concerned, is a platform or piece of software, obviously, that enables a distinctive hardware device to function on a specific hardware or a specific operating system platform, rather. So the drivers that you find associated with your Windows 10, for instance, would obviously be different with the ones associated with Windows 8.1, with Windows 11, or with any particular operating system that you can think of out there. So your Linux, Ubuntu's, and your Mac OS configurations in that regard, because they're specific to the actual operating system in that in that regard. So the type of hardware that is compatible with, obviously, that this particular type of technology there is obviously. So it mentions rather that this type of hardware is considered compatible with what type of technology in essence. And obviously what you're looking at in this regard is your distinctive plug and play as far as your configurations would go. Remember, legacy is just the same as old architecture. As far as, or in some instances, even if you want to be a bit more specific, possibly outdated, but legacy just means older architecture in that regard. Your plug and play there becomes distinctively your default go-to. So let's see if we can obviously add content as we go along here. So for the first one here, it's distinctively plug and play as far as your a specific environment there in that regard is concerned, right? And then when you look at your distinctive 1.2 question there, you're looking at a specific utility now that is used to prepare a newly installed machine for imaging to apply to other computer systems. So remember, with imaging, like we mentioned before, it's distinctively creating an exact copy of either a software package or a system at large. And we've been using images or ISO files for our assessments, both for network architecture and CNOS as well. What you're looking at in this particular regard is just the exact copy of a specific system, or the exact copy of a software package, if you want to look at it from a different perspective. And the reason why this is done, like we've mentioned in our previous sessions, is that it makes it easier for deployment of the operating system, inclusive of possibly specific drivers that are needed and other application packages that are needed as far as your environment would go. So just for argument's sake, if we look at your the computer room that we normally use for this particular module when we're on campus, you've got about possibly, I think, 50 machines in that particular venue. And as far as those machines are concerned, they're all similar, the exact same model, exact same configuration, and obviously exact same spec, if you look at it from a different perspective. So when you install your operating system on one machine, right, during that installation process, you obviously need to then ensure that the correct drivers are loaded to ensure that you've got optimal usage of that particular device or gadget. And in certain instances, you might also need to load other application packages, right, that would make usage of that machine a bit more specific in that regard. So literally, if you look at it from a different perspective, what you're actually looking at as far as your configurations would go would then be your operating system, right? So that's your main software, like we mentioned before, enables you to use your machine for a basic purpose, right? And then after loading your OS, you obviously then want to incorporate the drivers that obviously ensure that the hardware incorporated within this particular package itself, or within that particular device, is used without any discrepancies, right? So whatever particular hardware is there, from your board all the way to your generic keyboard, will need to be loaded accordingly to ensure that there are no issues in terms of usage of hardware components within that operating system, right? So now we've got a basic machine. But ultimately, since our operating system just enables us to use our machine for a basic purpose, we now need to make it specific. So your application package, remember, at the end of the day, enables you to literally ensure that you use your machine for a specific purpose. So now we might need to load application packages as far as your specific setups they are concerned. And ultimately, these application packages can range from your Office packages, for instance, your word processors, your distinctive spreadsheets, your presentation packages, you name it. And then you might want to load more specific application packages, for instance, like your PDF readers, Adobe as a typical example. You might want to then also load possibly some virtualization software that are type 2 or third party, like your VirtualBox. You might also need to then incorporate other packages like your Visual Studio as a typical example. So you want to then have that as the other part of installation as far as or preparation as far as your particular machine there is concerned, right? So we've loaded the OS, we've loaded the drivers, we now need to load the application package. So once that is done on one machine, because the rest of the machines are distinctively identical, exactly the same thing, you want to then create an image of that machine that you've just loaded the OS on, you've loaded the drivers on, you've also loaded application packages on that are obviously going to be used across the multiple machines by the different students on campus, as in our particular example. You can take an exact copy of that or create an image of it and then literally deploy it on all the other machines that are there. So that image would then include your OS, would include the drivers, would also include the application packages. So there is a specific utility, obviously, that enables you to prepare a newly installed machine for imaging across other similar computers that are obviously within the same setup in that regard. Some might want to argue that in certain instances, you also can use it across different machines where you might just want to load your operating system and possibly the application package in that regard. But in most instances, you obviously have similar machines. That's the reason why the drivers also become imperative in that regard, because it's similar across the board. So the actual utility that you're looking at in this regard is your sysprep utility. Remember, your DISM is your deployment, imaging, servicing, and managing platform that is there. But here we are looking at preparation of a newly installed machine for imaging in that regard. So what you're actually looking at in this particular instance would be your sysprep, which is that one there. And then with the third question, you're looking at your ACpi setup. And remember, ACpi is short for Advanced Configuration and Power Interface. And literally that particular setup is just a power management spec. Literally that was developed by Intel, Microsoft, as well as Toshiba, and just enables basic improvement of power management, right? And this is especially for portable computing. As far as your specific setup is concerned. So how you manage how the battery functions, how you manage how your particular portable machine works on battery versus when it's plugged into a power, as far as your specific setup is concerned, or plugged into the socket on the wall there in that regard. So there is different settings, if you look at it from a different point of view, that obviously enable you to put the computer system in what they call that ACpi power state in that regard. And from the list of options that we've got there, I think this is also part and parcel of some of the other research that I'd asked of you when we looked at this particular setting, and what you're looking at in this regard. As far as your configurations would go, we're looking at your S0 there. So you've got a couple of states that are there as far as your management setup there is concerned. So it's important to take distinctive cognizance of that particular fact. So your S0 there would naturally be the working state. And you obviously have other states there that are included, your S1, your S2, S3, S4 as basic sleeping states in that regard, which obviously the computer system would literally appear as if it's off, right? Because of the reduced power consumption. But it retains enough to obviously return to a working state without having to restart the operating system at large. Naturally, your state 5 is the shutdown, or your off state completely. So what you're looking at in terms of what literally puts the computer system in ACpi power state, which is literally the working state, is your S0 as far as your specific setup there is concerned. So once again, you've got states S1, S2, S3, and S4, which are all part and parcel of sleeping states, right? As far as your particular portable machines are concerned. Like I said before, in this particular state, you'll discover that your computer system appears as if it's off, obviously because of the reduced power, as far as consumption is concerned, but it would literally retain or keep enough to return to an actual working state without the need of having to restart the OS as far as your particular system at large is concerned. So what you're actually looking for is S0 there as far as 1.3 is concerned. And then question 1.4 now, we've got a preferred techno that enables us to set up disk storage with mirrored fault tolerance for a user backup data, or for a user's backup data. So what you're looking at in this regard is the moment we discuss fault tolerance as far as ICT is concerned, naturally what we're now looking at is trying to avoid or trying to safeguard against foreseeable disaster. What is this foreseeable disaster? And naturally, your hard drive crashing, or distinctively data loss generically, right? So by default, specific architectures were developed back in the day, and RAID is your default go-to when you're discussing fault tolerance, especially when you're looking at it from naturally your data point of view, right? Because we've mentioned this before, that the most The priceless component when it comes to your computer systems is naturally going to be the data, because everything else can be replaced, no matter how expensive it is, or no matter how difficult it might be to find or obtain. It's distinctively replaceable in that regard. But when it comes to data that is stored, once that is lost and there's no appropriate backup, then very difficult for you to get that content back, right? So in that particular instance, your redundant array of inexpensive or independent disks was designed to accommodate for that. And within that particular architecture, we've mentioned before that you've got your striped configurations, where data is written across multiple drives. But because it's written across, it means that bits and pieces of data are found on different drives. So if one particular drive malfunctions, you've got a obviously a propensity of you actually losing the data in its entirety in that regard. So it's part and parcel of RAID, but it's not actually a RAID. I think it's more applicable when it's used in combination with other type of RAID architectures, like your RAID 1, for instance, or your striping associated with RAID 0. Then you've got your RAID 1, which is normally associated with either mirrored or duplexed architectures. When you're looking at mirroring, you've got both drives, same drive letter, exactly the same copy of data. The only difference now is that when it's mirrored, you're using one disk controller. So there's an issue there from a speed point of view, right? Because you're using just one controller to write to the data or to write to the drives, rather, as far as configurations would go. But then when you look at duplexing, on the other hand, you've got two disk controllers, so one dedicated controller for each of the drives that are there, as far as your particular setup would go. So a lot faster as far as configurations would go, because you've got a dedicated controller for each drive that is there. That is obviously your RAID perspectives as far as configurations would go. Yes, you might also want to discuss RAID 5 and 6 with your distributed parity, and then extra bit parity as well, where you've got another set of drives that are used to check for the correctness of the data that is being written to the drives involved in that RAID infrastructure. So what you're actually looking at in that regard is that this becomes a bit more integral, if you look at it from a different perspective, because there is some kind of error checking mechanisms incorporated there to make sure that the data that is being written across the drives is actually correct and is not corrupted as far as content would go. So in that particular instance, right, there's another proprietary architecture that literally mimics the RAID configurations, but ultimately a bit more advanced in that regard. So Windows 10 or your Microsoft environments there would develop a proprietary architecture that works within the Windows perspective, that literally works hand in hand with RAID, or that mimics the way in which the RAID architecture functions, but are obviously a lot better. So what it will mean is, with this particular architecture, if you're already using RAID, then literally there's no need for you to use the proprietary Windows 10 configuration in that regard. And then on the other hand, same difference applies when it comes to you already using the proprietary architecture offered by Windows, especially within the Windows 10 platform. If it's already incorporated, then there's no need for you to incorporate RAID, because the architectures are literally one and the same. It's just that one is considered slightly better than the other as far as basic configurations in that regard is concerned. So what you're actually looking at in this regard, when it comes to your fault tolerance, what you're actually discussing there is an architecture called storage spaces. And I think this is also part and parcel of your assignment, especially if you look at question 2.2, where you are supposed to obviously create that type of fault tolerant architecture, obviously using the appropriate mechanism in this regard, which is your storage spaces. So 1.4 would be storage spaces. I think we've got other options that are there. So you've got basic dynamic hardware-based RAID 5 and then hardware-based RAID 1. But what you're looking at here is that it's a proprietary configuration, and we're discussing Windows 10 in this regard, right? So the proprietary architecture that you're actually looking at in that regard would be your distinctive storage spaces. as far as your configurations there would go. So yes, while you might have RAID 5, RAID 1 incorporated there, but the fact that you're looking at it from your Windows 10 environments, I think that's what's important in this regard. The fact that you're looking at it from Windows 10 environments there, then arguably your storage spaces becomes your default go-to in that regard as far as your configurations would go. All right, so that's that. And then I think the last question associated with the multiple choice, we're looking at authentication. So this, again, is overlapping from computer architecture as well as your cybersecurity module. Because remember, the moment you discuss authentication methods, you're looking at some semblance of security. And we've already mentioned that normally when you're looking at these authentication platforms, or when you're looking at security at large, you're normally discussing your AAA setups, right? Where you've got authentication, authorization, and then accounting. Some literatures might also want to mention auditing as accounting in that regard. But when you look at authentication, normally you're dealing with access, and arguably that particular access is looking at credentials. So normally these credentials, usernames and passwords, right? Electronic credentials that enable you to gain access to actual system or access to the network, you name it. And then authorization is now associated with the account. So when you gain access, there's a profile associated with that, right? And that particular profile is directly associated with an account, if you want to look at it from a different point of view, either locally or on the network, as far as your machines would go. And that particular account would have certain permissions or rights associated with it, right? So what is it that you can do on that particular computer system? What is it that you cannot do? And the same difference applies as far as your particular network is concerned. So authorization just looks at permissions, right? And then at the end of the day, when you look at accounting is associated with the whole concept, with more or less of an audit, like an audit trail, or some kind of report, or some kind of check to see what that particular profile or account did on the system. So you've gained access with authentication. You've got your permissions associated with your authorization, and then there has to be some kind of report, right? Or audit trail to check or to see or to have some kind of recording of what that particular profile or account did either on the local computer system or on the network. So that's what your accounting is all about as far as your setups would go. So it's part and parcel of the moment you find fingerprint scanners, the moment you're discussing retina scanners, the moment you're discussing palm readers, the moment you're discussing face recognition platforms, automatically you're now discussing biometric-based technology, right? That's all you're looking at in that regard. And remember, biometrics looks at using a human being's unique physical features to gain access to a specific system or network, whichever way you look at it, or to gain access to a specific environment as far as configurations would go. I think this was one of the questions that you also undertook as far as your computer architecture exam there is concerned. So biometrics is all about, our biometric-based technology is all about the whole concept of using a human being's unique physical features to gain access to either a system or a specific network or environment. And ultimately, typical examples of that biometric-based technology would include the fingerprint scanner that is listed as far as this question would go, would also include your retina scanners, your palm readers, your face recognition platforms as typical examples, and voice recognition as well as typical examples of those particular characteristics. So Microsoft obviously developed something specific, obviously, for the Windows platform that works hand in hand with this, or that literally is just biometric based technology, and the specific term or the specific configuration that is there associated with your Windows environments there would be Windows Hello. So option 3 there for our 1.5 becomes your default go-to as far as that particular question there is concerned. So that's your multiple choice in that particular instance. Like I was mentioning earlier on, that you got your 1 mark allocation. Sometimes upgraded to 2. And you might also even find that instead of having 5 questions, normally you might get 10 as far as your setups would go. So from an exam perspective, you possibly might get 10 multiple choice questions and then 10 match column-based questions there as far as your setups would go. Like I was just mentioning right at the beginning, that mark allocation ranges from 1 to 2 as far as your specific setup there is concerned. So in this particular instance now, we've got your match columns. So you've got a description in column A and obviously the actual term or function or configuration in column B. So you also have a 5-part contribution, and this is 10 marks, so that's obviously 2 marks apiece. And what you're looking at in this particular instance now is the first one is looking at a Windows a personalized voice assistant, that is used to accept commands. And naturally, that default setup is Cortana as far as your specific setup there is concerned. So as far as 2.1 day is concerned, our contribution would be D in that regard. And then when it comes to your a new feature in Windows 10 used to encrypt USB drives, that obviously, remember, whenever we're discussing encryption, as far as your specific setups would go, and naturally, the default proprietary architecture associated with Windows is your BitLocker. So a BitLocker normally is associated with actual drives that are part and parcel of the system. And the reason why it's incorporated as part of a security feature is that should you lose your particular machine, for instance, or should it get stolen, the drive that is there is automatically encrypted. So whoever was trying to access content there will need to have the appropriate key in order for them to decrypt or descramble the data. Remember, when you look at encryption, you're scrambling data into a non-readable format, right? And in order for you to descramble that data or to decrypt the data, you obviously need to have the appropriate key. So normally in very basic encryption setups, you normally have 2 types of keys that are there. You've got a private and a public key. Normally your public key is the one that is used for encryption across the board. And then remember that is literally accessible to everyone as far as just ensuring that you are able to encrypt data accordingly. But when it comes to descrambling that particular data or decrypting that data, that becomes a bit more of possibly sensitive area, for lack of a better expression. Why? Because you have to have that decryption or descrambling associated with a specific individual in your particular environment. So that individual rather would then have the private key that is associated with decrypting or descrambling the data. So this is part and parcel of what they call asymmetric encryption, and you also have symmetric encryption. Obviously, when it's asymmetric, you've got one public, one private, and normally when it's symmetric encryption, then you've got both similar keys for encryption and decryption as far as your specific environment would go. So when you're looking at BitLocker for your generic system, you also have a version of that encryption platform that was obviously designed for your portable drives or your portable storage platforms, your external hard drives, and obviously your flash drives are typical examples in that regard. So what you're actually looking at in this particular instance is BitLocker to go. So that would be F as far as that contribution there is concerned. And then a multi-factor authentication system that is incorporated within your a Windows 10 platform. So this is now different now, because now when you're looking at it from what we were initially discussing earlier on, we were looking at that Windows Hello, that's a part and parcel of the biometric setup. But when you're now looking at multi-factor authentication, so remember what this means is that you've got different types of mechanisms put in place to authenticate a user across multiple devices, just for argument's sake. So you've got a platform that was designed to enable individuals, obviously, to be able to access accounts and so on multiple devices, with using obviously the same kind of credentials or setups that are there as far as your particular configurations is concerned. So in essence, when you're discussing this two-factor or authentication, that would obviously either enable request you to incorporate a PIN or your personal identification number, and then also use another form of authentication, which is possibly the biometric platform that is incorporated there, as far as your particular setup there is concerned, for you to actually gain access to the system. So what you're looking at in this particular instance is what they call Windows Passport, right? So it's literally a key-based authentication system that is distinctively built into Windows 10, that obviously looks at just making access to systems a bit more secure in that regard, as far as your particular setup is concerned. So what you're actually looking at as far as 2.3 there would go is your Microsoft Passport, and that's your default go-to in that regard. And then you've got a portable version of Windows 10 that can be created on a USB drive. So this is something that you'd obviously use across different machines. You don't literally want to move around with an actual computer system, just for argument's sake. You can have your OS incorporated on your flash drive. So all you need to do is just plug it in and then run it from there as far as your particular setup is concerned. Once you're done, save your content, you remove your particular drive and you move along. So this just makes it a bit more convenient in terms of functionality, having to move around with the flash drive, as opposed to actually moving around with a computer system or multiple computer systems in order for you to access content in that regard. So what you actually are looking at in this particular instance is just a platform that makes it a lot easier in that regard. So what you're actually looking at in this particular instance is your particular Windows to go, right? That obviously enables you to create a basic workspace that obviously can be booted from a thumb drive in that regard. So your Windows to go is what you are looking at as far as this particular setup there is concerned. And remember, this is a particular feature that is incorporated within your enterprise and education platforms as far as versions of Windows is concerned, and it enables the creation of a workspace on a bootable thumb drive, right, or a bootable USB external drive, as far as your configurations in that regard there is concerned, right? So what you're looking at as far as that particular question would go is going to be your Windows to go, which is A, and then lastly, you've got a command line utility. So even without looking at it from a CNOS perspective, from what you've looked at as far as computer architecture and network architecture there is concerned, you've got a utility that you can use within the command line setup that enables you to check for connectivity as far as your particular setups would go. And that particular utility that you want to look at is your ping, right? The ping command is what is used to test for connectivity across all platforms as far as your network environments there is concerned. So as far as that particular question there is concerned, your answer in this regard would obviously be B. All right, so that's your contribution as far as that particular question there is concerned. So 2.1 is D, which is naturally your Cortana. Your 2.2 is then F, which is your BitLocker to go. Your multi-factor authentication, as far as Windows 10 would go, is your Microsoft Passport. And then 2.4 is your Windows to go, that portable version of Windows that can be plugged in on an external USB external drive. And then naturally for connectivity, you're looking at ping. All right, so that's your setup that is there. With question 3 now, 25 mark allocation as far as your configurations would go. Naturally, you've got a similar question that is part and parcel of the actual assignment that you're undertaking. I think for the individuals that were present when we looked at your 2.3 as far as your assignment is concerned, I think that was in yesterday's session. We distinctively looked at how to obviously disable this particular standard floppy disk controller. I think that was part and parcel of, I think if you are not mistaken, rather, I think that should have been the, the third part of 2.3 as far as the actual question would go. And literally after being given this distinctive screenshot as this particular paper there is concerned, you are now looking at a set of questions that have been incorporated there. So obviously the first one for 3.1.1 there mentioned that identify the actual hardware management tool that is shown in that regard for 2 marks. So remember, you've got multiple utilities that we've mentioned before, right, that are associated with the way in which your particular system runs as far as your generic configuration there is concerned. And then it's important to identify which is which and what these particular setups are responsible for as far as your configuration goes. And what we did in terms of accessing this particular part is to work with the device manager, right? And typically what that device manager would do for you, if you're looking at now 3.1.2 in terms of the any 4 tasks that are used as far as this particular tool there is concerned, device manager enables you to change hardware configuration options. It enables you to disable or enable hardware as you were asked of in your assignment. Which is the second one. The third one is identifying any conflicts as far as basic hardware devices they are concerned. And then naturally, the other thing that you can also do within your device manager platform is distinctively manage drivers. Those particular pieces of software we were mentioning earlier on that enable you to use specific hardware components within specific operating systems. So that's your 3.1 in a nutshell there. 3.1.1 is going to be your device manager. And obviously, as far as setups there is concerned, so I think here we can quickly mention that this is your device manager, right? And then as far as the actual tasks they are concerned, the 4 tasks as far as configurations there would go, like we mentioned before, manage drivers. So enables you to manage your drivers, right? Enables you to then also look at identify conflicts. So identify conflicts as far as hardware devices are concerned or between hardware devices, and then also enables you to enable and disable hardware. So enable and literally disable hardware. And then also look at, so here we can then say, and distinctively looking at hardware configurations as far as setups would go. So this would be changing or change hardware configuration settings or options. Hardware configuration settings there. Right, so that's your contribution as far as your setups there are concerned. And then for 3.2 now, if you look at what we've got, NTFS, your new technology file system. I think we've been singing this song for a while, ever since last semester, really, in terms of the actual differences between your file systems, which is your file allocation table, your initial file system, and your new technology file system. You also have extended FAT or exFAT incorporated there. Remember, we've mentioned that when you're discussing these settings, right, what you're looking at in that regard is the whole concept of just ensuring that you prepare your storage device for storage or for usage. And the part of that preparation process is to ensure that there's an applicable file system that is there. That obviously enables you to actually store content and then be able to access that content once stored. So with your NTFS setups, you obviously had a couple of advantages that were there. This is also part and parcel of the exam that you undertook, that with the different advantages that are associated with NTFS, you can discuss compression as part and parcel of that. To obviously maximize your storage space, you can discuss disk quotas to avoid monopoly of usage of an actual hard drive component, rather, when you've got multiple users associated with a specific machine. You can discuss encryption. We've just mentioned what encryption is all about. You can also even look at file and folder security, and more often than not, you're now looking at what they call the access control list, which is literally what they're asking in this particular instance now, in terms of when you look at files, what are the different permissions associated with any file or folder as far as your configuration would go. You can also discuss redundancy as part and parcel of an advantage or a feature associated with the NTFS. And then you can also even discuss the whole concept of cluster sizing. So these are all examples of the different advantages that NTFS has over FAT as far as basic configurations there is concerned. Now, ultimately, you're now looking at specific permissions associated with your given setup as far as your NTFS architectures they are concerned. So you just ask for any 5 of them. So what you're looking at there would be full control, modify, read and execute, read, write, as far as specific configurations there is concerned. You can also even mention, if you're looking at it from a folder perspective, list folder contents as part and parcel of that particular setup. So for this question here, you can discuss full control, which means that you can do anything and everything as far as your particular setup there is concerned. And the other thing that you also might want to discuss in this regard is modify. You also might want to look at read and execute. You also might want to discuss your read, naturally. You can also even discuss write. Like I mentioned before, you can also even mention list folder contents. That's if you're dealing with a folder, right? As a typical setup in that regard. So list folder contents. So that's your setup there. They've asked for 5. I think I've listed 6 there as far as your particular setup there is concerned. Or is it just 1, 2, 3, 4, 5, 6, right? So just a question of choosing what you want to go with as far as that particular setup there is concerned. So typically, that's your NTFS configuration there. I think, again, there's content for you as far as your specific setup there is concerned in that regard. So as far as that particular paper there goes, I think you can always go and look at 3.3 and 3.4. There's basic research in that regard as far as content is concerned. What I would also want to concentrate on, this is also part and parcel of your assignment. So 4.1 there, 4.1.1, 4.1.2 is also part of your assignment. So exactly the same concept that associated with your assignment there is what you're plugging in as far as content there is concerned. So they've asked you, describe how the password policy tool is accessed, and also explain any 4 password policy settings depicted above. So either enforced password history, maximum password age, minimum password age, your minimum password length, password must meet your complexity requirements, and then store passwords using reversible encryption. So like I mentioned before, this is actually part and parcel of your assignment, right? So that you should have enough content for that. And then also look at 3.3 and 3.4, question 4.1. I think what you also might want to, what we might want to discuss as far as content there is concerned, especially when you're looking at it from the networking side. This is also something that you should be familiar with. Remember, there's that Windows 10 networking lecture that was also uploaded a couple of weeks ago. As far as your content there is concerned, this material is already there for you. But just to make sure that we're all on the same page there, remember, you're all now familiar with IP version 4, right? And I think one of the main shortcomings of IP version 4 is the limitation in the number of accessible or usable IP addresses, right? And considering that you've got the 5 classes, but only 3 of them are accessible to the general public that obviously can be used in that regard. There's massive limitation, and it's been like that for a number of years now. That's the reason why obviously the IPv6 becomes more preferable as far as particular setups they are concerned, because naturally it offers a much bigger addressing space. So the whole concept or need of subnetting and NAT architectures, and in certain instances, even with the private addressing platforms that you've gotten accustomed to now, might not be relevant when it comes to IPv version 6 there, because you've got quite a chunk in terms of the addressable configuration that is there as far as IPv6 there is concerned, right? So with the first question for 5 marks, or the first part of 4.2 there, as far as 5-mark allocations would go, they've asked you to look at just a brief discussion on the actual improvements of IP version 6 over IP version 4. So now remember, when you're looking at such a type of question, or actually not just question, but if you're looking at it from a holistic point of view, what you're identifying in this regard is that IP version 6, like we mentioned before, is not upgrading IP version 4. It's an actual replacement of IP version 4. So naturally, there's always going to be some discrepancies when you are replacing something as opposed to upgrading it, because when you upgrade, you already have a foundation, you already have a platform to work on. But when you're replacing, it's as if you're obviously coming with a new technology or architecture altogether, right? So yes, there might be some teething issues, or there might have been some teething issues when that particular IP address was created, or addressing format was created. But there are obviously a multitude of improvements that are there as far as your particular setup is concerned. So what you want to include as far as contributions, especially for the first part of that question, is efficient. So here we can mention more efficient routing. You can also even mention, so these are just routing mechanisms there. So remember, IPv6 generically just reduces the actual size of the routing tables, naturally making routing more efficient and more or less work or distinctly incorporate some type of hierarchy in that instance. And you'll also even discover that IP version 6 ultimately allows ISPs to normally aggregate the actual prefixes of their customers' networks into a single prefix, and literally ensure that there's some kind of announcement as far as one particular prefix to the IPv6 internet space there is concerned. And then you also even discover that with IP version 6 networks, the whole concept of fragmentation is handled by the source device rather than the actual router itself. So remember, when you're looking at it from a generic IP version 4 networking perspective, a fragmentation of your networks is that particular exercise is allocated to the actual router, right? But in this instance, it can be handled by the actual source device in your network configuration, and this would obviously use protocol configurations for discovery for the actual parts maximum transmission as far as your particular setup there is concerned. So you've got more efficient processing when it comes to IPv4. You can also even discuss directed data flows. So the other thing that you also want to discuss here is directed data flows as far as your particular setup there is concerned. I think we can make this a bit more uniform across as far as your setup there is concerned. So directed data flows, that's another option that you can discuss in that regard. And in this particular instance, you'll discover that IPv6 would obviously support more of a multicasting type of architecture rather than a broadcasting type of architecture, right? And what we mean by this now, remember, with multicast, you're actually sending to specific users within a given setup or environment. Then broadcast is to everyone that is connected in that particular instance. So that is a massive advantage if you're looking at it from your network configurations in that regard. Because it's a newer type of architecture, naturally you'll find that it supports new services or newer type of services. So support, you can mention here, support of new services. Right, and what we mean by this, naturally, now remember, because it's eliminating NAT or network address translation in that regard, right? It then avails for true end-to-end connectivity, and obviously at the IP layer, as far as your configurations is concerned. So that true end-to-end connectivity is now literally restored. Ultimately enabling new and valuable services to be incorporated in that regard. So there's no need for some kind of translation between certain devices or entities within your network. What it means is that when you got connectivity, it's as if you're mimicking a peer-to-peer kind of relationship as far as direct communication in your particular setups there are concerned. The other thing that you want to also discuss here is simplified network configuration, right? Because there's no need for that segmentation we were discussing earlier on, the fragmentation we were mentioning earlier on, obviously associated with the actual router itself. So you now are looking at the whole concept of auto configuration or address assignment that is already inbuilt as far as your IPv6 configurations there are concerned. So here we can mention that this is simplified network config or network configuration. And then the other thing that you also want to discuss in this particular instance, right, is naturally going to be your security, right? While you also might want to add efficient packet processing, right? So in essence, you find that your IPv6 uses obviously simplified packet headers that make packet processing naturally a lot more efficient. Right. The other thing that you also want to discuss in this regard is obviously going to be security, because with your internet protocol security, which obviously provides confidentiality, authentication, and then data integrity, it's part and parcel of your IPv6. So it's actually incorporated within IPv6 as far as your setup is concerned. So you'll normally find that because of the basic potential of carrying malware. When you look at IPv4, certain ICMP packets are literally blocked. Normally, when you look at corporate firewalls, just to avoid any intrusion there as far as your malicious software there is concerned. But when you look at it from an ICMP version 6 now, the implementation of that Internet Control Message Protocol for IPv6 is permitted because IPsec or Internet Protocol Security is already applied to these packets as far as traversing the network is concerned. So naturally, you find that security becomes the default go-to there as far as your particular setup there is concerned. So these are some of the improvements naturally of IPv6 over IP version 4. And ultimately, if you look at it from a different perspective, right, like I mentioned before, if you can even mention here more efficient packet processing. So a more efficient packet processing. More efficient packet processing as a go-to there. Let's see if we can just bring this either up or down so that it's legible. Yeah, so we've got something like that. So this is what your contributions are as far as your 4.2.1 there is concerned. So these are just obviously some of the improvements in that regard. But again, like I mentioned before, not something that is set in stone. Again, you might even discover that when it comes to other literatures, there'll be different points incorporated there, but ultimately these are the underlying advantages that IP version 6 has as far as v4 there is concerned. But again, like I said before, not the only ones that are there, but those are the ones that obviously come to mind as far as basic configurations there would go. The other thing that you also want to discuss here is the actual format of IP v6. Remember, IPv6 is a 128-bit address, right? Which means that that's a massive jump from your 32-bit address setup that you've got. So normally with 32-bit configurations, as far as IP version 4 is concerned, you're using decimal in terms of representation of your IP address. But now, because you're using 128 bits, that means that 16 bits per 8-bit section, or per 8 section rather. So you've got 8 sections for an IP version 6 address. Each one of those 8 sections are represented by 16 bits. And naturally, that gives you the 128. So those 16 bits are represented by hexadecimal as opposed to decimal. Because if you look at IP version 4, you've got 32 bits and 4 portions. Each one of the 4 portions naturally represented by 8 bits. And these 8 bits are directly translated to your decimal. So in this particular instance now, you've got 4.2 now looking at ensuring that we can look at the shortest form of what is represented there as far as your IP version 6 address there is concerned. Now, remember, you've got leading zeros and zeros incorporated within, or consecutive zeros and leading zeros that can obviously be shortened to provide a better representation, if you want to look at it from a different point of view, rather, as far as your IP addresses there are concerned. So what you want to take into consideration here is that you've got specific rules that you want to take into consideration when it comes to your IP version 6. So when you're looking at shortening, a basic setup that is there, the first type of rule that you want to look at is that an entire string of zeros can be removed, right? But ultimately, you can only do that once when you're removing a string of zeros. So we've got a string of zeros associated with our particular IP address in that regard. The second rule that you want to also take into consideration when it comes to IP version 6 is that 4 zeros can be removed, right? Leaving only one single zero. So if we have a 4-0 platform there, we can remove it and represent those 4 zeros by only 1 0. The system would automatically populate the remaining zeros for you. And then the other rule that you also want to take into consideration is that leading zeros ultimately can be removed. So leading a string of zeros, and then obviously your 4 zeros can be represented by 1 in that regard. So if you look at the IP address that we've got right in front of us there, we've got FD 00, and then obviously a string of zeros within the 5 sections that are there. And then leading zeros, you've got A0 and then 00 F1, and then obviously the subnet there, or the prefix rather, is going to be 64 bits as far as your particular setup there is concerned. So ultimately, first of all, if you want to rewrite this now to shorten it, we've got our FD, right? So our zeros are still incorporated, but because we've got a string of zeros, as you can see, we've got a string of zeros here, 1, 2, 3, 4, 5. We use that colon, right? Remove all of these zeros and incorporate or use the last colon there. That would typically represent the string of zeros that are incorporated in this particular IP address. So we've just shortened that by removing 1, 2, 3, 4, and 5 in that regard, right? As far as your particular setup is concerned, right? And then what you want to now then do is that you've got leading zeros also here, right? So these 2 zeros are leading zeros. So anything before an actual representation or within the actual section there is incorporated. So that means we now are supposed to state our A0 there, right? And then we also have leading zeros here before F1, right? So in that particular instance there, it now means that our IP address would be shortened to that. So that's the representation. That's the shortest form of this particular IP address that you find on screen now. So you've got your FD00, you've got the double colon, right? That are literally representing the string of zeros. And then you've got the leading zeros here that we've removed before A0 there. We've got another set of leading zeros there before F1 that we've removed. Your final IP address would look something along those lines there. So in essence, when you're looking at it from a distinctive perspective, right, your computer system would automatically populate the missing zeros, for lack of a better expression, right? It will do that for you. So that's how you'd obviously represent your IP. Even when you're incorporating the actual IP version 6 in the computer system, it will automatically do that for you as far as your particular environments are concerned. All right, so that's your paper at large. I think we're good to go in terms of content. Like I mentioned before, for question 4.1, that's within your assignment. You should be able to answer that accordingly. 3.3 and 3.4 doable in that regard, as far as content there is concerned. All right, so that's the 2019 paper there as far as the revision is concerned. Just ensure that obviously later on when I upload this, you also use that content to prepare accordingly. We want to avoid a computer architecture scenario where the content was there for you, but seemed as if most individuals did not bother to go through that content as far as preparation for your assessments are concerned. All right. So that's that when it comes to revision there. Do we have any questions, contributions, or concerns from anyone? Any questions, contributions, or concerns from anyone there as far as this particular paper is concerned? Questions, contributions, concerns? All right, so it seems nothing's coming through, so I'm assuming we're good in that regard. We'll conclude the session at this point. Stay safe, keep smiling. We'll see you in the next one. Cheers.